Chapter 7 or Network Architecture. So in this chapter, we're gonna talk about the Ethernet, Gigabyte Ethernet, Token Ring, Apple Talk Environment, FDDI, other network alternatives, chapter summary, and key terms. So what is network architecture? So it refers to the way network device and servers are structured to serve the connectivity needs the client device. Network device typically include switches and routers, and types of servers include DHCP and DNS. The client devices comprise an end user device server and start things. So what is Ethernet? Typically, Ethernet cables are used to provide an Ethernet connections, provide devices to a local network. They plug into Ethernet ports on a variety of devices. The most common use for an Ethernet cable is connecting a Wi-Fi router or modem to the internet entry port or telephone line. And this is the example of how or what Ethernet cable looks like. An overview of Ethernet. So Ethernet is defined by international standards, specifically IEEE 802.3. It enables the connections of out to 1024 nodes over coax, twisted pair, or fiber optic cable. Most new installations today use economically lightweight cables such as Category 5 unshielded twisted pair cables and fiber optic cables. So below's photos, this is the example of multimedia repeated with up to 7 Tenet modules and how the transfer being processed. So 10 Mbps IEEE standard. So in this slide, it's defining Ethernet LAN standard name. So as you can see here, the original name of IEEE is 802.3i, and also after the original name, the IEEE shorthand name is being discussed as well. Informal names, speed, typical cabling, so on and so forth. So this is the summary of Ethernet naming. So if you wanted to learn more about this one, you can just focus on reading this page. So 100 Mbps or IEEE standard. So what is it? It is the fastest Ethernet was able to deliver data at a rate of 100 Mbps, which has a significant improvement over the original 10 Mbps Ethernet system. It was released under IEEE 802.3u in 1995. Although technology has moved on significantly to standard like 1000 Mbps or 1 GB Ethernet and given 10 GB Ethernet, but still the old fast Mbps Ethernet is seen, specifically the guess of 100 base T, which has the Ethernet over Cooper and used with Cat5 cables. Gigabyte Ethernet 1 GB or IEEE 802.3 AE standard. As the name suggests, Gigabyte Ethernet has 1 GB or 1 GE, allows the transfer of data at speed of 1000 Mbps or 1 GB per second. It is particularly easy to install because the 1000 base T variant is designed to run over Cat5 or UTP or unshelled twisted pair Ethernet cables that are widely and cheaply available. So what's next for Ethernet? The future of Ethernet bright and fast. Implementation of 40 GB Ethernet and underway. Estimations are that Ethernet could increase tenfold every 4 to 6 years, giving us 10 or 100 GB per second Ethernet by 2006 to 2008. Terabit Ethernet 1000 GB by 2011 and 10 terabit Ethernet by 2015. So this kind of mind-boggling speed will be able to transfer data across the city faster than today's CPUs can transfer data to memory. Ethernet frame types. There are basically two different types of Ethernet networks, Ethernet 2 or Ethernet 802.3. The IEEE 802.3 frame can be encapsulated in an IEEE 802.2 LLC frame or a snap frame. All four names are enabled by default, and your network print server will automatically adapt the frame used or frame type used in the network. So this is the example in the right side for the four type of names of Ethernet types. Ethernet 802.3. 802.3 or IEEE 802.3 is a working group of standard specifications for Ethernet, a method of packet-based physical communication in a local area network maintained by the Institute of Electrical and Electronics Engineers. 802.3 defines the physical media and the working characteristic of Ethernet networking. So what is segmentation? It is a network security technique that divides a network into a smaller distinct sub-networks that enable network team to compartmentalize the sub-networks and deliver unique security control and services to each sub-network. So the picture on the right side is the example of segmentation and how segmentation looks like. So wireless internet or IEEE 802.11b. So what is it? It is a amendment to the original standard was ratified in 1999. So 802.11b has a maximum raw data rate of 11 Mbits and uses the same Ethernet-based in signaling protocol. Due to the CSMA's or CA protocol overheads, in practice, the maximum 802.11 throughput that an application can achieve is about 5.9 Mbits over TCP and 7.1 MB over UDP. It also operates in the unprotected 2.4 GHz frequency band with an 83.5 MHz wide channel. So if we have wireless Ethernet IEEE 802.11b, we also have IEEE 802.11g. So on June 12, 2003, a third modulation standard was ratified, 802.11g. Also using the 2.4 GHz band like 802.11b with an 83.5 MHz wide channel, it operates at a maximum raw data rate of 54 Mbps or about 24.7 Mbps through path like 802.11a. It is fully backwards compatible with D and uses the same frequency. Details of the interoperability between D and G occupied much of the technical process. In order network, the presence of an 802.11b would significantly reduce the speed of an 802.11 network. So what is token ring? Token ring network prevents data packets from colliding on network segments because only a token holder can send data and the number of tokens available is also controlled. When a device on the network successfully decodes the token, it receives the encoded data. So on the right part, you can see how the token ring travel. So it has a process. So what are the token ring functions? By using token ring or token passing channel access method, token ring networks ensure that all computers get equal time on the network. As discussed in Chapter 6, a small frame called the token passes around the ring. A computer receives the token from its nearest active upstream neighbor or neon. If the token is not in use at the time, no neighbor computer is sending data, and the computer has the data to send. It attaches its data to the token and sends it to the nearest active downstream neighbor or NPV. So each computer thereafter receives the token, determines that it is in use, and verifies that the data destination is not itself. It's not. The computer recreates both the token and the data exactly as it's received them and send them to its destination. So in this page, as you can see, token ring summary. This is the token ring summary. So you can see the 7 to 9 category. It has the category and the summary as well. So I'm just gonna leave it here for you and you can see it by yourself. So hardware components. So computer network components are the major parts which has needed to install the software. Some important network components are an IC, switches, cable, hub, router, and modem, depending on the type of network that we need to install. Some network components can also be removed. Cabling in a token environment. So as we said lately, token environment or cable has three parts, and the coaxial, unshielded twisted pair or UTP, and fiber optic. So cabling in a token environment is the set of wires made of either copper or glass that is used to connect computers and other network components to enable them to communicate, thus forming a network of computers. So AppleTalk environment. Apple Computer Incorporated designed the AppleTalk architecture for use in its Macintosh network. AppleTalk can run over a variety of other physical architectures, including Apple's own local talk, Ethernet, and Token Ring. Because Ethernet's superior speed and large installation base, AppleTalk is most commonly run over Ethernet, sometimes referred to as EtherTalk. As it's introduced, AppleTalk referred to the networking protocol and the hardware used to connect computer in 1989. Apple changed AppleTalk's definition to refer the overall architecture of the network and added the term local talk to refer to cabling system. So, because of the connector's configuration, a local talk network more often resembles a tree rather than a bus. So as you can see in the figure 7 to 9 or figure 7 to 8, an Apple Computer Incorporated designed the local talk network architecture which uses STP in a bus topology to allow users to share peripherals and data in a small home or office environment. The local connectors consist of 3 connectors, one of the computers and 2 like the one figure. So what is FDDI? FDDI or Fiber Distributed Data Interface is a network standard that uses fiber optic connections in a local area network that can extend in range up to 300 kilometers or 124 miles. The FDDI protocol is based on the Token Ring protocol. So FDDI LAN can support thousands of users. So as you can see in figure A, figure A is the example of Token Ring protocol, and it the same, or it's where FDDI was being copied or reassembled with. So in figure B, it's how core switch is being processed as well, and how this FDDI works. So it is used mainly in mission critical and high traffic network where large amount of data flows need to flow quickly and effectively. It has become the mainstay access method of high-speed network in local area and metropolitan area network in many places. So other network alternatively, many other network architecture are available. Some are goods for specialized applications and others are emerging as a new standard. So, broadband technology. Broadband technology is the transmission of wide bandwidth data over a high-speed internet connections. Broadband provides high-speed internet access via multiple types of technologies, including fiber optics, wireless cable, DSL, and satellites. So, what is broadcast technologies? It is to explore the ever-changing world of televisions, radio, internet, entertainment, and commercial video performance. Students will work in collaborative team to produce video projects using relevant AV equipment, and editing software. Special emphasis is placed on creativity, writing, and editing classes. Asynchronous transfer mode or ATM. ATM is a switching technique used by telecommunication network that use asynchronous time duration multiplexing to encode data into small fixed size cells. This is different from Ethernet or Internet, which use variety pack size of data or data or frames. ATM and SONET signaling rate. So as you can see here in table 712, optical pair signaling rates from OC1 to OC307. So as you can see here, the optical pair destination has its own variety and it's defined the signaling rate. So you can just read this by yourself and learn more about its signaling rate and optical pair destination. So high performance parallel interface or HIPPI. It is a standard point-to-point protocol for transmitting large amount of data at up to billion of bits per second over relatively short distance, mainly on local area network. Data is sent in bursts of 1024 or 2048 bytes on an unidirectional channel. So that will be all for this chapter, and this will be the chapter summary of this discussion. So you can just go quick to read everything in here for the short discussion and the key terms. This is the terms that being used and its meaning as well. So chapter 7 ends here. So that will be all for today, and also this will be my references where I get my resources. So everything